Good morning, good afternoon, everybody. Welcome to what I think is one of the most timely conversations we could be having in enterprise AI right now. My name is Yves Laurent, and I lead the technology partner ecosystem at Couchbase. Now, over the past 2 years, companies have been experimenting with AI, but there's the challenge right now is how to get a DIM to work is really easy. Getting AI to work reliably, securely, and at scale in production, that's an entirely different ballgame. We have moved past the what is generative AI conversation and are now into why isn't this working the way we expected? The gap between a compelling proof of concept and a production grade AI system is much wider than what most teams anticipated. The reasons for the gap is data fragmentation, latency, security, concurrency, and just the complexity of stitching different tools and platforms together. And now Agentic AI is raising the stakes even further. We're no longer about asking models to answer a question from a static document. We're asking AI agents to reason, retrieve, and act in real time against live operational data. And that requires fundamentally different architecture than what most teams built during their early experimentation phase. Now, that's what today's conversation is about. And to help us unpack this, I'm joined by two guests that I've been working with very closely over the last couple of quarters, Kieran and Jeremy. Now, Kieran, why don't you start introducing yourself, and then I'll pass it over to Jeremy.
Sure. I'm Kieran Matty. I'm the lead PM for AI/ML here at Couchbase. I've been with Couchbase a little over 2 years. I look forward to this conversation. Over to you, Jeremy.
Hi, my name is Jeremy Cornett, and I'm in strategic alliances at NVIDIA, and I've been at NVIDIA for about 6 years.
Well, thank you both for being here, and I know this will be a great discussion and conversation. Our session today will cover 4 areas. One is the drivers behind the partnership. Why are we working together? What are our respective AI strategies and how is that coming together? Then we'll cover what it actually takes to get AI systems into production, which is at the heart of the conversation. And then also let's speak a little bit into the future. Where do we see this headed over the next 12 to 18 months? Now, for you in the audience, if you have any questions during this session, feel free to drop your questions into the chat window, and we'll get to it at the end of the session. We'll also follow up with you if we didn't get to your question, and then we'll follow up later on and get back to you. Now, let me start with the first question. The best partnerships are solving real challenges that customers are actually experiencing. And in this case, enterprises have AI models that need to make fast, high-quality decisions. But the data that those models depend on sits into operational systems. Kieran and Jeremy, I'd love to start with the why behind this partnership. What gap did you both see in the market that made this collaboration valuable to customers, especially as AI applications move from experimentation into production? So Kieran, why don't you start off with giving your perspective, and then we'll pass it on to Jeremy.
Yeah, sure, Yves. I'm going to work off of the point you made earlier. Agents work fine in POCs, but when they hit production, that's when things fall apart, right? And there is a statistic that Gartner, I forget the analyst firm put out. It was around 90% of the POCs, agentic POCs don't make it to production. There are many reasons that drive that, but we'll focus on 2 reasons here in this talk. The first one is around data inference collocation. And the reason that is required is there are many applications like conversational agents, customer service agents that require consistent performance around throughput and latency. And with network latency that is added by hitting public endpoints, that is not achievable. And this has come up in many customer conversations. So we thought this is a problem we should tackle head on. And there are a few other reasons why it makes sense to bring inference and data closer. The other one is around predictable costs. So there are many workloads that are stable in nature. For those, you need dedicated pricing. You can't go with token-based pricing. So the collocation of data and inference helps with that. And above all, the main theme or the main problem that customers bring up is around data privacy. There are many customers that cannot tolerate their data traversing the internet. So this is enterprise data that we are talking about. And finally, the problem that we wanted to tackle was around air gapping. So air gapping is a concept where your AI infrastructure that includes your data platform is not supposed to connect to the internet. So it's basically disconnected from the internet, and this is mostly prevalent in highly regulated markets like healthcare, financial services, and so on. And this is where Jeremy and his team came in and helped us provide a service, a model service within Capella, which is our DBaaS service, where we offer leading models from providers like Meta, Llama, Nemotron from NVIDIA, Mistral, and Snowflake, DeepSeek models, and so on, as a service from within Capella. And we have augmented that experience with services like caching. So you don't have to invoke your models for queries that are semantically similar, that are identical word for word. So we have a caching solution that is baked into our model service. And in addition to that, we also offer guardrails, thanks to NVIDIA, based on their NEMO guardrails. Customers can author policies that comply with their enterprise needs. And yeah, I'm going to turn it over to Jeremy to take us.
Thank you, Kieran. Great. Yeah, so one of the things that we saw between prototype and production early on was that a lot of IT policies were being sort of set aside in the interest of moving forward with these prototypes. So there was a lot of excitement around trying things out with AI, and organizations would allow their teams to go and develop these prototypes. But when it came to pushing these to production, in part because they worked around the standard policies, things like security and performance were much more challenging to push through in terms of getting these components to production. And there were a lot of concerns about pushing into production. And so many times these prototypes weren't pushed to production, even when there was value there. So NVIDIA has put a lot of work into trying to help our partner ecosystem to have tools that really adhere to the enterprise processes, one of those being NVIDIA NIM. So doing things like providing releases on a regular basis and securing the whole stack are areas of focus that NVIDIA has had in order to be able to sort of bridge that gap between prototype and production, and to smooth the process of pushing things into production so that there's confidence not only in things like security, but also in the predictability of performance. If you are on the hook for the cost around the tokens, you need to be able to have predictions of what that's going to cost so that you can develop your business models. And that's really critical to being able to ensure that these things can really see production use.
Great. Thanks, Jeremy and Kieran. Let me move on to Kieran to the next question. From Couchbase's perspective, what challenges were customers facing when deploying AI models that require that tighter integration between inference, infrastructure, and operational data?
Yeah, good question, Yves. So once the enterprises realized that the benefits of the data inference collocation, they went down this path of building their DIY stacks, actually, which I can assure you is not that trivial. And based on the conversations that we have had with customers, it takes anywhere between weeks to months actually to stand that up. So that is basically wasted time, the time that they could have invested in building or focusing on their applications or their own infrastructure. So the solution that we have come up with in collaboration with NVIDIA makes it very easy. Actually, we have a workflow that we offer as a part of our UI experience, where customers can select the models of their choice. As I mentioned to you, there are a wide range of models supported by NVIDIA that we offer, and then they can select the performance out of the box performance profiles, either for low latency or high throughput, and then they can select the value-added services that include caching, guardrails, and other services. And yeah, so the experience has been fairly seamless, and thanks to NVIDIA, the collaboration really made it happen.
Yeah. Now, from NVIDIA's perspective, inference performance has always been very critical. But it turns out the relationship between where a model runs and where the data lives matters enormously in production. So, Jeremy, why is pairing GPU accelerated inference with an operational database so critical for enterprise AI deployments?
Yeah, this is actually one of the things that I was really excited about in the collaboration with Couchbase. Capella has all of these great capabilities, and being able to have proximity between the data and the inference is critical. I think what we've seen over time is that very often out of the gates, organizations would sort of choose their AI capabilities over here, and they house their data over here. And it turns out that in order to really have things not only be efficient, but also be accurate, you've got to have the use of that data in order to drive that. And there's so many areas where that makes a difference in building your AI pipeline. Certainly things like RAG, being able to pull data in as a part of the prompt, but also as you're developing these solutions, being able to tune your models based on the data that you have available can really have a huge impact on the ability to drive your accuracy. And it turns out that you can use smaller models and tuning in order to drive better results than you would get from larger models without that tuning. And so, obviously we want to get the results out of these AI pipelines in terms of the types of responses and the accuracy of those responses. This is key to having value around the solution overall, but we want it to be economical, and we want to pay as little as possible for every token that's going through the pipeline. So having the data and inference together is absolutely critical in terms of being able to achieve that.
Yeah, very good. Now,
hey, Yves, I would like to add
Sure.
something to what Jeremy said and back it up with the numbers. So here on the database side, Couchbase is a performant database. We provide sub-millisecond latency for KV lookups. We have a performant vector store, operates at a billion scale. So we are basically marrying that experience with what Jeremy just mentioned around the inference performance. And we have some numbers to back that up. Using NVIDIA NIMs compared to our DI by stack, vLLM based, essentially, we saw a 4x increase in time to first token, which is an important metric to measure the efficacy of AI models, roughly 3 times the throughput compared to our system that we used prior to using the NIMs, and faster end-to-end latency as well. So it was basically fusing these two performant entities, the database, fast database, and fast inferencing that helped our customers build innovative conversational experiences that require very low latency.
Yeah, thanks. Now, Kieran, the next question gets here to the heart of agentic AI, right? Why is operational data like live session state, transactional context, real-time user insights so important to model quality for AI agents and RAG applications?
Yeah, so the agents are as good, or their reasoning capability is as good as the data that is fed to them. If you look at an operational database, it contains, or rather, it captures the real-time state of your entire business. And it is up to date, it is current, and that is the context that is fed to the agents to make decisions that are grounded in reality. We can reduce hallucination with that. So yeah, an operational database is critical to provide context to performant agents.
Yeah. So, Jeremy, if operational data is really the fuel for AI quality, latency is the enemy, right? So, on every millisecond that data has to travel between systems is a millisecond of degraded experience, if you will, that compounds at scale. So, Jeremy, how does collocating inference services powered by NVIDIA alongside operational data in Couchbase reduce latency and improve the quality of AI responses in production?
Yeah, I think across the board, in terms of your experience on interacting with AI, having all of that in one location is going to help to improve your experience. I think we see things kind of going in two directions. We have sort of the chatbot experience, where we expect fast response, and we expect that we're going to be able to see that response come up as soon as we submit it. But there's also reasoning, and reasoning takes a little bit more of a gradual approach, but absolutely critical to that process is the data that's being fed in. And we're getting to a point where the context window being 1 million tokens is sort of the new standard. And so it's not just your prompt that's going into that context window, but it's all that data that you're getting from that local data storage that's helping to ensure that every process after that is going to give you the results that you're looking for. And so even latency in those situations is something that makes a big difference. So being able to pull that data in, making sure that the reasoning and the plan that's put together in order to get you the response is taking advantage of that local data as well, is going to make sure that you're getting the value out of these agents that you expect.
Yeah. Yeah, thanks, Jeremy. Now, Kieran, one of the practical questions architects ask when evaluating a new technology stack is this right for my specific use case, right? And so which types of enterprise AI workloads benefit the most from this kind of joint architecture and solution between Couchbase and NVIDIA? And what makes this approach particularly well suited for those use cases?
Yeah. Yves, I think I hit on this earlier. One, I think the biggest driver or the criteria to select this architecture would be the data model collocation, right? Or the data inference collocation. And there are several drivers for that. One of them, as I articulated earlier, is around cost predictability. There are certain situations where token-based pricing doesn't cut it. So you need a provisioned experience for that. And this is not something that we are saying. Actually, our customers have been telling us, the users of our model service have been telling us that. The other one is around data privacy, or any agent that needs to be developed in an air-gapped environment. You can't use public endpoints for that, right? So you need something that is hosted on-prem. And NVIDIA offers that through their NIM operator, actually, where customers can leverage a whole host of models from the NGC catalog, deploy them on-prem, and use that in conjunction with the data services, the AI services that Couchbase offers around vectorization for automatically vectorizing, ingesting unstructured data and converting them to vector indexes and indexing them to our performant vector search, or using SQL statements against LLMs. We call that capability AI functions. That's used for sentiment analysis and summarization and a whole host of other mundane tasks that can be automated. So there are a whole lot of benefits that this architecture brings, in addition to the one that I mentioned earlier.
Yeah, yeah. Now, let me stay with you, Kieran, for a moment here. There is no one size fits all when it comes to AI deployments, right? And some organizations are fully embracing managed cloud services, while others operate in a tightly controlled on-prem or hybrid environments where they need full control over their infrastructure. So Kieran, how does Couchbase AI strategy adapt across both Capella, our, as you said, fully managed DBaaS solution, and Couchbase Server for self-managed deployments, and does the experience for developers and AI workloads remain consistent across both? Can you elaborate a little bit on that?
Sure. So our deployment strategy is essentially two-pronged. One of the prongs is around targeting the air-gapped situations that you talked about, right? There are many customers in highly regulated markets that cannot tolerate their data traversing the internet to these public endpoints. So in those situations, we offer our customers a model service in collaboration with NVIDIA, where the customers can deploy their models on-prem and use that in conjunction with our Couchbase Server. As you know, some millisecond latency and the performance profile that I had shared earlier can be leveraged with it. And that enables a whole host of use cases where, again, air gapping is a requirement. The second segment that we are targeting are customers who have their data currently resident in the cloud. So we want to support them as well. And you talked about Capella DBaaS service. So that's where they use our model service backed by NVIDIA NIMs in conjunction with Capella. And these models, as a matter of fact, are hosted within the Capella perimeter. So the data never leaves our customers' data perimeter.
Yeah. Now, Jeremy, let me come to you here. You talked about NVIDIA NIMs earlier on. And so how does NVIDIA NIM simplify the deployment of optimized inference endpoints for models like, as Kieran mentioned, Llama, Mistral, Nemotron? How does that change the pace at which enterprises can get models into production?
Yeah, I think this is really important to our strategy to try to help our partner ecosystem to quickly implement these models. I have something I can share here in order to help to explain a little bit about what we're doing with NIM. So let me pop this up here. So some of the things that we focused on in terms of NIM are the ability to really drive this in a portable way, which allows you to take these containers that have all of those elements that are a part of standing up an inference stack, within this container. So all of these have been security screened. All of these are version controlled. We have branches for both production and feature. They're very easy to use. And it's a great way to be able to immediately drive something that's production ready. And obviously we focus on performance. So performance is a big part of what we try to drive, not only in terms of latency, but also throughput. And what we've seen with these models is that we continue to drive additional technologies for optimization. And where many places, organizations may be happy to see 5 or 10% improvement in their performance around the cost of these things, which can have a direct impact on the bottom line, we're regularly seeing multiple X performance improvements in these models over time. So if you look throughout a year or two, you're going to see sometimes 5, 10X performance improvement. And if you think about this from the perspective of the tools and applications that you're building, this has a huge impact on the costs around running these applications, which is ultimately going to directly impact your ability to scale these up, which is one of the key issues that Yves mentioned out of the gates. So some of those things that we're driving with these NIMs, certainly a wide variety of different types of AI generative models, certainly text and speech, but also other categories of models as well. All of those dependencies are all sort of taken care of and all scanned. So all the VEX information, all the vulnerability information is available as a part of the publication of these containers. So it's ready to go out of the gates. Often with prototyping, we see that there isn't really a strong understanding of what the performance is going to be. But if you're using a NIM, it's already performance optimized when you're initially putting it into the prototype. So you know what you can expect in terms of that thing being pushed into production as well.
Yeah, thank you, Jeremy. Now, Kieran, how would you describe that orchestration model between Couchbase and NVIDIA components, and what does that mean practically for teams designing or migrating to this architecture?
Yeah, so our architecture is fairly simple. It comprises two layers. There's a control plane, and I talked about the control plane earlier, the UI aspect of it, which we're talking about the Capella control plane here. It allows, it provides a fairly workflow kind of an experience where users can select models. So we have a subset of models from the NGC catalog that we expose to our users. They can pick those models, select the performance profile, low latency or high throughput, select our value-added services that includes caching and async processing or guardrails and so on and so forth. And it's just within a few clicks, their model is ready to be deployed. Our models are all OpenAI-spec-compliant, and that is something was one of the criteria for choosing NVIDIA NIMs. So that makes it very easy for application developers to port or migrate their existing applications, OpenAI-spec-compliant applications, to our platform. And then let's talk about the data plane. We have a separate tenant for each customer. And this is something that they had requested for compute isolation. So the NIMs are deployed in the customer's tenant, basically, and exposed via the OpenAI interface to their applications.
Yeah. Now, one of the concerns we hear sometimes from enterprise architecture teams is vendor lock-in. How does this joint architecture help customers avoid lock-in while still capturing the performance benefits of optimized GPU and database integration?
Yves, do you want me to take that, or?
Yeah, please.
Okay. Yeah, I'll go first, Jeremy, and probably you can chime in. So from a vendor lock-in perspective, we, as I mentioned to you earlier, our requirement was that the interface between the applications, agentic applications or RAG or what have you, and the model service needs to be OpenAI spec compliant. And so with that, the advantage is, even if the models change, so we are talking about the OSS models from NVIDIA, even if they come in and or are deprecated, the interface still remains the same. Actually, so as the model landscape evolves, the applications remain unaffected because of this interface. So there's no vendor lock-in. They can use any of the leading providers here provided by NVIDIA NIMs like Snowflake or Snowflake embedding models, or Mistral, Nemotrons from NVIDIA, Meta, Llama, Mistral, and so on, DeepSeek for that matter.
Yeah, I think another really important component around vendor lock-in is having the flexibility to run these workloads wherever you like. And certainly Couchbase provides solutions that can be running in the cloud like Capella, but on-prem type of implementations as well. So having the ability to run all of these, including NIM, in any kind of environment, any of the clouds, on-prem, any of the neo clouds, all of these are possible with the platform.
Yeah, thanks. Now, as I said at the beginning of this session, AI demos typically are designed to work, right? However, production environments deal with more complexity. And so when real users hit a system at scale, specific things start to fail. So Jeremy, what breaks first in production AI systems when concurrency scales up? And what should teams be stress testing before they go live?
Yeah, I think certainly one of the things that we've seen with these AI capabilities in general is that when people do see the value around them, when they've had a chance to work with them, it leads to a lot of excitement, and it leads to a lot of use of these tools. So the ability to scale this across infrastructure is really important. It's one thing to run a particular model But certainly, if you're going to launch this across the organization, you need a different level of scale, and this actually creates some opportunities around efficiency as well. So just in the last couple months here, in addition to what we've done with NIM, which we do have the ability to drive these workloads out to NIM running on a large number of systems. We also have just announced the capability of running NIM with Dynamo, which is our distributed inference server. And not only does this make it easier to basically spread those workloads across a large set of infrastructure, but it also creates efficiency optimizations as well, where now you can see, again, another layer of multi-X performance improvements, taking advantage of caching that ultimately drives greater efficiency as well. So, having that ability to scale, is something that's really critical to being able to make sure that we're able to have our users take advantage of these capabilities. And obviously, it's got to have the uptime and all of those necessary elements for people to trust it and use it over time.
Kieran, anything else on your end you wanted to add?
Yeah, sure. I would like to add to what Jeremy just said, right? So there are two aspects here. One, on the data layer side, Couchbase is built for massive scale. We are a memory-first architecture, and in addition to that, we have several other capabilities as well that make us suitable for deployments with such heavy scale. And on the model side, as Jeremy mentioned, right, we do have a scale-out architecture. So we check for certain metrics like end-to-end latency and scale out our NIM infrastructure to handle massive scale. And yeah, so that has helped our customers productionize their AI workloads thus far.
Yeah, thanks, Kieran. And it's a good setup for what I was planning to ask you in my follow-on question. So Couchbase support the kind of high throughput, low latency access patterns that production AI demands, and specifically when handling both vector embeddings and operational JSON data simultaneously. So did you want to expand a little bit around how Couchbase bring a number of those capabilities together as a fully integrated operational data platform for AI?
Yeah, sure. So I think I mentioned this earlier around memory-first architecture, right? So there are the I/O latency is minimal, and then in addition to that, we support something called as MDS, which allows us to scale out our services, and that's on the data layer side, built for heavy or massive workloads. And on the model side, we use a lot of optimizations from NVIDIA as well, like continuous batching. And so this is available out of the box. We do the tuning for our customers, and which allows or rather supports massive concurrency. And in addition to that, we have our built-in caching capability also, where for semantically similar or identical queries, we serve up the request from the cache itself. So that makes sure that the GPU resources are utilized well. And this kind of architecture can support massive concurrency as well, because the traffic is offloaded from the GPU infrastructure to the database. And yeah, so this is currently used in production, and customers are happy about it.
Yeah. And staying on the same theme, Jeremy, I was wondering if you wanted to add the NVIDIA angle here on, how does GPU inference actually behave under high request concurrency, and what has NVIDIA built into NIMs to optimize for both throughput, latency when demand spikes? Did you want to touch on that?
Yeah. So, I think this is absolutely critical to having these applications that you're building be economical. So, we built NIM so that they have the ability to optimize for latency and throughput. But there's a lot of other tools that are available in order to help to ensure that you're getting the most economical solution overall out of the pipeline that you're building. And what we're kind of seeing more commonly as we look into the future is that all of these applications are multi-model applications. It's not just a single model. As Kieran mentioned earlier, there's embedding as a part of the model, but also, you may have multiple LLMs that become a part of the solution. Some of it may be based on the nature of the query that's coming in, that it's routing it to a particular model. But we're also seeing routing based on complexity. So if we're talking about latency and we're talking about efficiency, being able to take a very simple query where the response that's necessary for that query is significantly in the database and you're pulling it out as a part of your RAG pipeline, you don't need to route that to the largest model. You can route that to a smaller model that's much more efficient in responding, much lower latency in the response. It doesn't have to have reasoning as a part of the response that it's providing. And ultimately, you're providing all of the response accuracy that's needed by the user, but you're doing so much more quickly and much more efficiently in terms of the overall cost.
Thank you. Now, let's talk about security here for a moment. AI introduces attack surfaces that traditional security frameworks simply don't account for, right? Thinking about model extraction, prompt injection, data leakage, and these are all real enterprise risks that need architectural answers. Now, Jeremy, what security risks are unique to AI inference workloads, and how does NVIDIA AI Enterprise help enterprises secure both model deployment and their GPU environments against them? Yeah, and then I'll pass it over to Ron if you had any additional additions to provide.
Yeah, so there's a whole category of models that NVIDIA has been developing called our Nemotron safety models that are interesting from the perspective of providing some AI-driven approach to things like identification of PII, as well as our guardrail solutions. So guardrails is largely a framework that allows you to use a variety of guardrails, and we've got a whole partner ecosystem around that enables expansion of guardrails for a variety of different purposes. But AI does open a lot of attack surfaces ultimately that are new to organizations. And still the cyber solutions that are out there today have a lot of applicability. So if you have enterprise cybersecurity that you're utilizing within your enterprise today, and you're running Couchbase solutions on-prem, you can still take advantage of a lot of those technologies. But also, within the Couchbase solution, you're getting things like guardrails that help to provide protection for things like prompt injection and also just malicious use, to make sure that, those standards, apart from the general security of the platform, those standards that you have within the organization, that you're not allowing people to ask for HR information, or you're not allowing them to have queries that ask for a response to the types of information that you don't want coming through your pipeline.
Now, Kieran, how does Couchbase enforce data security and access controls, like for sensitive operational vector data and AI deployments?
Yeah, that's a good question. So data security is top of mind for us and our customers. So there are several controls that we have put in place for that, starting with the single tenancy, right? So the models are deployed in the customer's own tenant. And the reason for that is we don't want the data to leave the customer's data perimeter. And this is especially important when you're building RAG applications where the enterprise data needs to be sent to embedding models for vectorization. So this requirement came from our customers around that. The next one is around guardrails. Jeremy touched on it. So we use Nemo guardrails to offer services like PII detection, hallucination detection, off-topic detection, and so on and so forth. And the way we have integrated this into our services, the experience is fairly seamless. So the user just selects these attributes when they create a model in our UI experience, and yeah, we deploy it behind the scenes for the user, so they don't have to stitch together these models for prompt and response guardrails. And finally, we have something called as the agent tracer, which captures the trace information for the agent's decision-making process. This is very important for auditability and explainability, actually, which is an important topic in the AI world. And yeah, so security is something that we have been continuously investing in to make sure it rises up to the enterprise grade that we are shooting for.
Yeah, and absolutely foundational and essential to production systems, right? Now, we spend a lot of time on where things stand today, but agentic AI, as we all have seen, is evolving very fast, and the architectural requirements are going to evolve with it, right? So how do you both see the evolution of agentic AI impacting database and GPU architecture over the next 12 to 18 months? Jeremy, do you want to go first, and then we'll hand it over to Kieran?
Sure. Yeah. So I think the connection between the data and the AI pipeline becomes even more critical. So all of the things that we talked about end up having an increased impact on the ability to efficiently run these AI pipelines. Between the agents that we're seeing now that will, take workloads and give you responses and give you, data back again, and what we see happening with long-running, more autonomous agents, the need for, security within these environments and the need for the connection to the data is only amplified. On top of that, the value that you get from connecting the data into these pipelines becomes amplified as well. So if you have a job that's running for 15 to 30 seconds and you can increase the efficiency of that through the connection to that data, imagine the efficiency that you're going to get when you have something that's running 10 to 12 hours. This is going to really make it a clear decision as to whether these solutions are economical or not. We're seeing huge value created with these autonomous agents, and the ability to implement them in the enterprise is something that we really want to help happen. But ultimately, it's through our partners like Couchbase that are going to determine whether the enterprises are getting value out of these solutions and having the ability to run them in a predictable way with the security that they need and the connection to the data. The connection to that data becomes even more critical as we look at things like personal agents, the ability to house all of the historical transactions and the personalization of those agents for individuals.
Yeah. Kieran, did you want to add to that?
Yeah, sure. So I'm going to build on what Jeremy mentioned about agent autonomy, right? So as agents become more and more autonomous, I think that would warrant the data and inference to come closer to each other, actually, but that opens up a whole host of other problems as well, where we would need stronger guardrails, stronger traceability, and stronger governance. So I see a lot of investments going into that space as agents become more autonomous.
Yeah. Thanks. Now we'll close with the question that I believe every architect or engineering leader is asking themselves. Given everything we've covered today, architecture, trade-offs, production realities, if you could leave customers with just one principle to anchor their AI deployment around, what would that be? Jeremy?
Yes.
That's an incredible question. So I would say that, that you really do want to make sure that you're driving AI into an area that's going to create value for your organization. You already have the data. I think the question is, how are you getting value out of that data? If it's just sitting there today, you're asking your employees to go and find that data in order to get value out of it. So the connection between these language pipelines and the data is something that is immediately going to give people access to open up that data and get value out of it. So I would say that that's a great starting point for being able to create agents that are going to provide value to the organization. This is not a destination; it's a journey. Things are moving so quickly that your agentic work today is going to turn into your autonomous agents in the future. So there's a ton of value to get there today. I think as we look to the future, it's just going to amplify over time, and in terms of making our colleagues more efficient with these technologies and being able to do our jobs better.
Okay. Kieran, did you want to?
Yeah, I would just echo what Jeremy just said, and it's mostly value driven. I think architects and folks who are building their agentic systems should think about bringing data and models closer, inference closer. Actually, there are a lot of benefits to it that we talked about in this talk. And yeah, we look forward to seeing more of that collocation happening in enterprise environments.
Yeah. Well, hey, Jeremy, Kieran, this has been an incredible, valuable conversation. Thank you so much for this. What I'm taking away from this discussion is that the path from AI experimentation to production isn't just a technical challenge. It's really an architectural discipline, really. And it requires the right data infrastructure, the right inference layer, and the right partnership between platforms that were built to work together, right? And clearly you guys covered how that takes shape between Couchbase and NVIDIA. Now, I'm not sure if we have any questions that either of you would want to address.
Yes.
Otherwise, we can follow up separately after this session. In any case, Kieran, Jeremy, thank you so much for your time. It was a pleasure to moderate this panel with two very knowledgeable people. I hope you within the audience and listeners took away a lot of value from this, and we'll hope you join us for one of those future sections as well. Thank you so much.
Thank you.
Thank you.